Here are the solutions for questions 6 and 7 from the 8.3 Day 2 worksheet. Please have your 8.3 Day 1 worksheet, your note packet, and a calculator. You are strongly encouraged to work these problems out with me instead of just writing them down. Make sure you're plugging things in so that you can get the same results that I do. Question 6 on the 8.3 Day 2 worksheet is the same question as question 8 on the 8.3 Day 1. However, there's a few differences that'll help us find side lengths. It starts off the same. Two ships leave a port at 9 a.m. One travels at a bearing of north 53 degrees west at 12 knots, and the other on a bearing of south 67 degrees west at 16 knots. So that part's the same as the Day 1 worksheet. It then says, how far apart will the ships be at noon or at 12 o'clock? If we sketch what this picture will look like, we're going to start at the port, like where both ships are initially. So I'll just label that point P for port. Now it says the first ship, or one ship, travels at a bearing of north 53 degrees west at 12 knots. So if we draw in our north, and it's north 53 degrees west, it's going to be over a little more than halfway. So we'll draw that in. There's the ship. Okay, our angle is 53 degrees. And now it says at 12 knots. So if it starts at 9 o'clock and it travels at a rate of 12 knots, that means at noon it'll have traveled for 3 hours. So 12 knots for 3 hours would be a total of 36 knots. Okay, and then that's that first picture. The other ship is at a bearing of south 67 west at 16 knots. It doesn't say it traveled 16 knots, it's going at 16 knots. That means 16 knots per hour. If this one's south, I'm just going to go in the exact opposite. Whoa, maybe. Try that again. We'll go in the exact opposite direction, and it's going 67 degrees west. That means that angle is going to be a little bit larger than the first one. So we'll say somewhere down here like so. So there's well, let's get rid of that arrow on the inside. Whoops, not highlighted. All right. There we go, that's better. So there's our 67 degrees west, and it's traveling at 16 knots from 9 until noon. That would be 3 hours. Therefore, 3 times 16 is 48. That would be the distance the ship traveled by noon. And we're asked to find how far apart the ships will be. So now what I'm going to do is simply connect from one ship to the other. And we're looking for that segment again. Our pictures should be pretty consistent as far as setting them up. We end up using law of cosines quite a bit. Now, in order to use law of cosines, we're going to need that angle in the middle. And if you recall from the worksheet when we just kind of labeled everything we could, looking at this picture, we've got the 53 at the top, the 67 at the bottom, but together from north to south, that should be a total of 180 degrees. Therefore, to get theta, if we do 180 minus 67 minus 53, we end up with 60 degrees left over. That's going to be that angle on the inside of the triangle. And if we know that, there's our side angle side comparison. To get the length of that opposite side, we'll do law of cosines. So what I want you to do right now, please, is pause the video and set up the law of cosines formula. See if you can get all the way to the answer, or just get as far as you can. Once you feel you've gotten to the point that you can get to, press play and we'll see if we can have a match. As I plugged in the numbers for the sides and angle into the law of cosines, I got x squared equals 36 squared plus 48 squared minus 2 times 36 times 48 times cosine 60. Now this one's interesting. This is one of the first ones I think we've had that once we type all of it in, we don't have a decimal approximation. X squared is exactly 1,872. Does anybody know why? That would be because cosine at 60 degrees is 1/2. It isn't a big decimal that we approximate. At any rate, once we take the square root, you should get x is approximately 43.3 knots. That's how far apart the ships would be at noon. Our final question on the 8.3 Day 2 worksheet is problem 7. This one doesn't have a ship or an airplane, it's just a parallelogram. This question starts off similar to question 9 from the 8.3 Day 1 worksheet. So take a look at that one. A parallelogram has side lengths of 70 and 110 centimeters with an included angle of 70 degrees. All I'm going to do is start off by generating what that picture will look like. So we have side lengths of 70 and 110 and an included angle of 70 degrees. That just means one of the angles inside that parallelogram is 70, and it's between the 70 and the 110. That's all. If I sketch my parallelogram, and it doesn't really matter the direction, I'm just going to make it look somewhat like this. Parallelograms have opposite sides parallel and congruent, or equal to each other. If I label the smaller side length 70, and that longer side length 110, then it's safe to assume that the opposite side is 70 and 110 as well. Now the included angle would be 70 degrees. If you look at this parallelogram the way it's drawn, we have an acute and an obtuse included set of angles. The acute angle would be the smaller angle between the two, the obtuse would be the bigger. That means this angle right here is 70 degrees, and this angle over here on the right would be 180 minus 70, which is 110 degrees. So if you remember from the 8.3 Day 1 video, it was kind of interesting that the angles matched the sides. Not common, it doesn't happen every time, it's just on this particular example. Okay, so then what we're asked to do is find the lengths of each diagonal. The unique thing about a parallelogram is that the diagonals won't necessarily be the same length. That's only true if you have a rectangle or a square. So what we have to do is draw in a diagonal and see what we can do. I'm going to first start from the top left and go down to the bottom right. And what I've done, is created a triangle within this parallelogram. And if I label that side length X, we've got side, angle, side. So we've got SAS. That means we'll do law of cosines. How convenient. We've done that quite a bit. Law of cosines. That'll help us get that X. So if I do x squared equals, you guys do it. Pause the video like you did on problem 6 and set this up. It should be pretty straightforward, and then press play and see how you did, and then we'll look at getting the second diagonal length. When I plugged in the numbers, I got x squared is approximately 11,732.890. Taking the square root, the length of that first diagonal is approximately 108.3 centimeters. But here's the thing, like I said, that's not guaranteed to be the only diagonal length. If we try to create the other diagonal, I would go from the other two corners, opposite end to opposite end. That's kind of messy, so I'm going to take that one and just recreate my parallelogram. If we have 70 and 110, 70 and 110, and I'm going in that opposite direction right here, we'll call this Y, then the angle in between is 110 degrees, not 70. So really all that means is that's the only thing we're changing in that formula. If we do law of cosines to get Y, it's going to be Y squared equals 70 squared again plus 110 squared again minus 2 times 70 times 110 times cosine 110. Type that all in at once and you're going to get a bigger number than we had the first time. Check this out. Watch what happens. When we type in y squared, or when we get all of that, we get y squared equals 267.110. And if you take the square root of both sides, you would get y is approximately 149.2 centimeters. It should make sense that that length is bigger for the diagonal because the angle that it's across is bigger than 70. Here are all of your answers for the 8.3 Day 2 worksheet.